Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss when an electromagnetic wave is propagating through ionized gas or plasma, then what be the concept regarding electrical conductivity of this ionized gas, plasma frequency, refractive index of that of medium, skin depth, and so on. Let's begin. We have derived the wave equations that govern electromagnetic field vectors E vector and S vector for a particular ionized medium. That will be the equation in terms of E vector. This one is the equation in terms of S vector. Equation 1. So, the solutions of these two equations are in the form as E vector is equal to E naught vector e to the power I k dot r minus omega t. Similarly, for that of S vector, S naught vector e to the power I k dot r minus omega t. Solutions corresponding to these two equations. Now, putting that solution in equation number 1, what we have? Therefore, equation 1 becomes anybody can put in place of E that solution result, or simply by taking the form in place of grad operator and del by del t operator, we can easily simplifying without putting that solution result. Okay, that's why for equation number 1 we can put I k vector dot I k vector E vector minus mu naught sigma in place of del by del t minus I omega E vector mu naught epsilon naught in place of del by del t minus I omega square E vector is equal to 0. As we say, in place of del operator we use ik, and in place of del by del t operator we use minus I omega. Instead of taking the value of E is equal to E naught e to the power that and differentiating these results, we can easily substitute its operator form and simplifying it. Here I square minus 1 k dot k square E vector minus minus plus I mu naught omega sigma E vector plus mu naught epsilon naught omega square E vector is equal to 0. I square as minus 1 minus minus plus. Overally taking minus as common, or we can say multiplying negative sign on both sides, we have k square minus I mu naught omega sigma minus mu naught epsilon naught omega square common E vector is equal to 0, or let I prefer it as equation number 3. Similarly, by proceeding in that of same way, that second one can be sensed. Similarly, k square minus I mu naught omega sigma minus mu naught epsilon naught omega square whole into h vector is equal to 0. Equation number 4. As we say, but E vector not equal to 0, h vector also not equal to 0, then that bracket term must be 0. Then k square minus I mu naught omega sigma minus mu naught epsilon naught omega square is equal to 0. Therefore, k square is equal to I mu naught omega sigma plus mu naught epsilon naught omega square, or k square taking common mu naught epsilon naught omega square, that term as 1 plus this one as I sigma divided by epsilon naught omega. Not confused. First I write that term, next this one. Let prefer it as equation number 5, whereas sigma is equal to, but we say sigma is equal to I n square divided by m omega, which is called electrical conductivity of ionized medium. Now we have to derive is that value for electrical conductivity of ionized medium or not. Come to this. Electrical conductivity of ionized gases. As we are dealing with the propagation of electromagnetic waves through ionized medium, which is called plasma, we can analogy of the propagation of electromagnetic waves through ionized gases or plasma to when a moving charge along, or we can say moving charge through that of electromagnetic waves or electromagnetic fields, then it experience a force. When a moving charge through that of electromagnetic fields, then it experience a force. That force is due to electric field as well as magnetic field. Similarly, in case of the propagation of electromagnetic waves through ionized gases or plasma, nothing but the charged particles, positive or negative charged particles, we can assume that these charged particles are not colliding with each other. That is why simply we can say that is the force experienced by these charged particles due to electric field as well as magnetic field. So that the force is given by due to that of electric field E into E vector, that small e is the charge of electron and E vector is the electric field associated with that of electromagnetic waves, plus E into V cross B vector. Here V is the velocity of that electron and B vector is the magnetic induction associated with that of electromagnetic waves. So that first term relates to the force experienced due to electric field, and that second term relates the force experienced by that of magnetic field. Now the concept of force as mass into acceleration, here small m is the mass of an electron, for acceleration that is the rate of change of velocity, dv by dt is equal to that much. Look here how magnetic field is relates to that of electric field in case of electromagnetic wave propagation. As we have already known that B vector is equal to n cap cross E vector divided by C vector. E vector is perpendicular to that of B vector and it is related to 1 by C times of that one. Therefore, its cross product magnitude as VB. In place of B we substitute E by C. Look here, if that magnitude is very less than that of E vector. Why? Since V by C, that quantity is very less than 1 for non-relativistic case. For non-relativistic case, the ratio of velocity to that of velocity of light, when we compare, that is very less than to 1. That is why that cross product magnitude is very less than E vector. Now in the second term, the cross product of V and B can be neglected, only first term exists. Therefore, m dv by dt is equal to E into E vector. So dv by dt is equal to that m is divided E into E vector divided by m. Now we put the value for that of E vector. E vector is equal to E naught vector into e to the power I k dot r minus omega t. Again look here, for rapidly oscillating electric field, the displacement is small in comparison to that of wavelength. That is why k dot r vector, for k vector, that is the wave propagation, or we can say that is the wave number, 2 pi by lambda into n cap into r vector. As we say, n dot r is very less than to that of wavelength. The displacement is small in comparison to that of wavelength. N dot r is very less than lambda. Then we can say in that of e to the power this term, k dot r is neglected, only minus I omega t exists. In this term, e to the power minus I omega t. Overall, dv is equal to dt into that much. Integrating both sides, dv constant term to the outside of that of integration. Next, integrating that one, we obtain this. So E naught e to the power minus I omega t, that is nothing but E vector. So if there are capital L number of electrons per unit volume in that of ionized gas or plasma, then we can say the current density arising from the motion of these electrons. So the current density, n total number of electrons, E charge of electron, velocity of that of electron, n e, then the expression for velocity we put it here. Simplifying it, we obtain j vector is equal to I n e square divided by m omega into E vector. As we know, the current density is equal to conductivity into E vector. Comparing equation number 3 and equation number 4, we obtain the conductivity is equal to I n e square divided by m omega, which is the expression for conductivity of that medium. Which is the medium? That medium is ionized gases, or we can say plasma medium. simply conductivity as we derived it. Okay. Next, simplifying it, putting the value of that conductivity or k square is equal to mu naught epsilon naught omega square 1 plus I, in place of that sigma, I n e square divided by epsilon naught omega m omega, or k square is equal to mu naught epsilon naught omega square 1 I square, it is minus 1 n e square divided by epsilon naught m omega square. Here we can use the relation as c square is equal to 1 by mu naught epsilon naught, as c is equal to 1 by under root of mu naught epsilon naught. Simply using that relation, we have k square is equal to omega square divided by c square 1 minus, again a substitution is used, omega p square divided by omega square here omega p square is equal to n e square divided by m epsilon naught. Therefore, k is equal to under root of that term, that is omega by c 1 minus omega p square divided by omega square whole to the power half. Here the term as omega p is called plasma frequency. That plasma frequency is the angular plasma frequency. The angular frequency, the plasma frequency, that is the angular plasma frequency. And as you know, omega p is equal to 2 pi fp. Therefore, fp is equal to 1 by 2 pi into omega p. Therefore, f of p is equal to 1 by 2 pi, in place of omega p, that is n e square divided by m epsilon naught under root. Here f of p is called plasma frequency. That one as angular plasma frequency, this is simply plasma frequency, the expression for angular plasma frequency and plasma frequency. Again, we derive the expression for refractive index for such medium in the sense ionized gas or plasma. As you know, refractive index of a medium is given by n is equal to c divided by v, c the velocity of light to that of velocity of the light in that of given medium, which is equal to c divided by velocity omega by k, which is equal to k c by omega, or n is equal to, let I say, c by omega into k. Here the expression for k as omega by c, that much. The expression for k omega by c 1 minus omega p square divided by omega square under root c c, omega omega cancel out. We have n is equal to 1 minus omega p square divided by omega square under root. This is the expression for refractive index. Or again, in place of omega p, if we substitute that value as 2 pi fp and fp terms of this, then again we obtain the refractive index n is equal to 1 minus fp divided by f square under root. The refractive index in terms of angular plasma frequency. This is the refractive index in terms of simple frequency. Next, by using the plasma frequency concept, we can easily understood how electromagnetic waves are propagating through ionosphere. Our atmosphere, above that of our atmosphere, there will be troposphere, stratosphere, mesosphere, thermosphere and ionosphere. Ionosphere is nothing but that medium which is ionized gases or plasma medium. If we propagate radio signals or any kind of electromagnetic signals, how these signals are affected by our ionosphere, you can understand it. So for high frequencies omega is greater than omega p, therefore omega p by omega is less than 1. Here we say refractive index when omega p by omega is less than 1, omega p by omega less than 1, so refractive index n is equal to real in the sense, for high frequency range the wave propagates freely. If that electromagnetic wave have high frequency, then it can easily propagating through that of ionosphere. Why? Mathematically it can be clear. Omega square is very greater than omega p square, means when omega square is very greater than omega p square, then that n tends to unity, n is equal to 1, n tends to unity, which again a constant. So the transmission of wave is unaffected by the presence of ionosphere. Simple concept, when that frequency is greater than that of plasma frequency, when the frequency of that electromagnetic wave is greater than the plasma frequency, then we can say the electromagnetic wave propagation is unaffected by the presence of ionosphere. Next, when omega is less than omega p, that frequency is less than that of plasma frequency, then simply the refractive index expression 1 minus omega p square divided by omega square under root is imaginary, as that term is less than 1. So the refractive index is imaginary. So we can write the wave propagation k is equal to omega by c into, in place of n we write its imaginary form in. Therefore k is equal to I omega c divided by, as 1 minus this term, instead of this we can write omega p square by omega square minus 1 under root, as n is imaginary. So E vector will be E vector into e to the power I k, in place of k vector, that is k into n cap dot r vector minus I omega t. Here k vector I omega by c n dot r vector minus I omega t. I square minus 1 minus omega n divided by c n cap dot r vector into e to the power I omega t. Here we can substitute omega n by c as beta. So, E is equal to E naught e to the power minus beta n cap dot r vector into e to the power I omega t. That is the amplitude term. Look here, that the amplitude term gradually decreased with the increase of distances. So, S vector like in this form. From equation number A and B, it is found that electromagnetic vectors E vector and S vector get attenuated, or we can say that is fall exponentially with the distance from that of surface n dot r. That is why the electromagnetic waves for the region omega is less than omega p, that the frequency is less than to the plasma frequency. Therefore, that electromagnetic wave reflected from that of plasma. Okay. From the first point, when that frequency is greater than plasma frequency, then it is transmitted without affecting by the presence of ionosphere. But in another condition, when that frequency is less than that of plasma frequency, then it is reflected by the presence of ionosphere. Okay. Next concept, skin depth. The skin depth or penetration depth for the plasma is given by delta plasma is equal to 1 by beta. We clear what is skin depth or penetration depth, that is the distance travelled by that particular electromagnetic wave through that of medium. What will be the distance? 1 by beta, 1 by this of beta omega n by c, omega by c n, the value of n is putted omega p square by omega square minus 1, simplifying it, delta for that of plasma medium c divided by omega p square minus omega square under root, or the condition when omega is very less than that of omega p, as obviously when it is very less than that omega p, then it is reflected from that of medium. So, delta for that of plasma is equal to c divided by omega p. That will be the expression for skin depth in case of electromagnetic wave propagating through that of plasma medium. So, here with the help of this video lecture, we understand the concept of when electromagnetic wave is propagating through that of ionized gas or plasma medium, then the expression for electrical conductivity by putting that electrical conductivity, we derive what is plasma frequency. This is for angular plasma frequency and for simple plasma frequency. Next, what is refractive index? Next, how that electromagnetic wave is propagating through that of ionosphere. Basically, the condition for propagation when omega is less than omega p, that frequency is when that frequency is greater than that of plasma frequency, then it is transmitted without affecting by that of ionosphere. Another condition, when that frequency is less than that of plasma frequency, then it is reflected back by that of plasma medium. And finally, what is skin depth or penetration depth? So, with this useful and informative notes, let me wind up the session. Thank you.